love the way you hold me. I love the way you hold me. I love the way you hold me. I love the way you.
I've had a long day, I just wanna relax.
Hi everyone, I would like to answer this problem of finding the complete solution of this non-homogeneous differential equation. Why we know that this equation is a non-homogeneous? Because as we all know that the function of x here is not equal to 0 as we look this situation. And therefore, by finding the actual solution or finding the value of y, we must first get the complementary solution, and after finding the complementary solution, we will now get the partial solution of this equation. And now, let's go to the complementary equation. In solving the complementary equation, we must think this function and equate the function of x equals to 0. That this will be now our homogeneous equation. Now we must get the complementary solution and equate this equation, this function, into f of x equals to 0. Therefore, it will now be our homogeneous equation. After equating this into a homogeneous equation, we must equate y double prime into m squared and y prime into m equals to 0. Then, by factoring out, we get m times m plus 1. Therefore, we now have the value of m1, which equates to 0, while m plus 1 is equals, and we note this as our m2 is now equal to negative 1. By looking these two roots, they are not equal, therefore they are distinct real roots. And according to the case number 1, y complementary now is equals to c1, which is our constant, e to the m1 x plus c2, our constant, e m2 to the x. And therefore, as we look in our above situation, we have our problem m1 equals to 0. Therefore, c1 exponential to 0 plus c2 e to the negative x. Now, we get the value of y complement, which y complement is equal to c1 because e exponential to 0 is equals to 1. So therefore, c1 plus c2 e to the negative e of x. Now we are already have done getting the y complement, and now let's go to finding the partial situation of this problem. By looking on this equation above the problem, we now note that this equation will be our basis as our function of y of x, where x plus 1. By considering this situation, we must look the situation that results with this answer. And now, by observing this, a, which is our constant, e mx plus b x e to the mx plus c x2 e mx. And now, by equating the previous result of Rm, we know that Rm, m1 is equals to 0 and m2 is equals to negative 1. And now, by observing this, we must equate this situation e mx to 0 so that we have the value of 0 of this equation. So therefore, by cancelling the a, we already have the y partial, which is bx plus cx squared. And now, by derivative, we now have the derivative of bx is equals to b plus the derivative of cx squared equals to 2cx. And now, we already get the y prime of this yp. And now, we now get the double prime of this situation. And now, by considering this, we have the 2c as our final y double prime. By substituting this y prime and y double prime into the given equation, we now conclude that yp is equal to bx plus cx squared is equals to this situation now. Having this y double prime as a result here, we substitute it here, and then the y prime as this also, let's substitute it here by the given equation. And now, let's all equate this into x plus 2. By collecting like term, we now have 2c plus b plus 2cx equals x plus 2. And by seeing this equation, we must collect like terms. As we know that c and b are all constant, therefore, we must also equate these two variables into constant also. Therefore, 2c plus b equals to 2, whereas 2cx equals to x, which have the same variable of x. Therefore, by cancelling the x, we now have c equals to 1/2. After getting the value of c, we may now substitute it to the function to this variable. And now, by substituting it, 2c plus b equals to 2, we must transpose this 2c, so it became negative 2c. As we know that c has a value of 1/2. Therefore, 2 divided by 2 was negative 1. 2 minus 1 equals b. We now get the value of b and c. As we know that we have this partial equation, therefore, we must substitute this value into this equation. Having the value of b of 1, therefore, it became an x. And this one will be 1/2 of x squared. So now, we already have our yp partial. As we know that our function, our general solution will be this equation, yc plus yp. As we have discussed earlier, we already conclude that yc is equal to c1, which is the constant, plus c2 e to the negative x, and our y partial is x plus 1/2 x squared. By equating all these two variables, we now have the general equation, which is y equals to c1 plus c2 e to the negative x, which is our y complement, plus 1/2 x squared plus c as our y partial. So that's the end of our solution. Thank you for listening.
The
Bye.
way you hold me,
Hello everyone, it's me again. I'm going to discuss how to solve an equation using the how to solve a higher differential equation by using the Cauchy-Euler equation having an auxiliary equation. As we have this problem, x minus 2 to the squared y double prime plus 2 times x minus 2 y prime minus 6y equals to 0. By considering this situation, we now have a homogeneous function because f of x now is equals to 0. And now, by thinking the Euler equation, we have that auxiliary equation having this formula where a times m minus 1 plus bm plus c equals to 0. By looking this function, we have here a value of 1 which is our a, and here 2 which is our b, and here negative 6 as our c. By substituting this value, a equals to 1, b equals to 2, and c equals to negative 6, by the auxiliary equation, we now get m times 1 times m minus 1 plus 2, which is our value of b, times m minus 6, the value of c, equals to 0. And now, by multiplying this m, we now get m squared minus m plus 2m minus 6. And now, we must collect like terms. Therefore, m squared plus, because 2m minus 1m is equals to positive m minus 6. By looking this equation, we are now using a quadratic form to get the value of m. As we have the formula of quadratic equation, m is equals to b minus b plus minus square root of b squared minus 4ac over 2a. By considering this value a, b, c by this equation alone, having a as 1, b as 1, negative 6 as our c. Therefore, we now have negative 1 plus minus square root of 1 minus 4 times 1, the value of a, times negative 6, the value of c, over 2 times 1 as the value of a. Therefore, by equating all this number, we now have negative 1 plus minus square root of 25 over 2. And having this equation, we now have the value of m, which is m1. We denote this as m1 is equals to negative 1 plus 5 over 2. Therefore, we have now 4 over 2, which equals to 2. And now, by looking the another value of m, which we denote as m2, is equals to negative 1 minus 5 over 2. Minus 1 minus 5 is equals to negative 6 over 2. We now get the value of m2 as negative 3. And now we already have the value of m1, which is equals to 2, and the value of m2, which equals to negative 3. By looking these two variables, we have m1 is not equals to m2. Therefore, we conclude that these two roots are distinct. By looking this and having the equation y function is equals to c1 x to the m1 plus c2 constant of c2 x m to the 2. Now we substitute this value of m1 and value of m2 in this equation to get the general solution. Therefore, y equals to constant 1 x to the 2 plus c2 x to the negative 3. And now, let's the general solution of our equation. Thank you for listening. Hello everyone, and now I'm also presenting to you another equation involving a Euler equation and having an auxiliary. And now, by this problem, x2 y double prime as x y prime minus y equals to 0. And therefore, as we know that f of x equals to 0, it will be called as homogeneous. And therefore, we now go to our solution, having our equation, auxiliary equation, a m times m minus 1 plus bm plus c. And by looking above equation, we have the value of a as 1, value of b also 1, and the value of c is negative 1. By substituting these three values into our auxiliary equation, we have now m times m minus 1 plus m minus 1. And we now distribute this m. Therefore, we have m squared minus m plus m minus 1. And we now can cancel these two values. Therefore, we have m squared minus 1, and transposing this negative 1, it will become a positive 1. And now, when we know if we have m squared, we must transfer this value of squared. Therefore, m will have positive square root of negative 1. We know that square root of 1 is 1. Therefore, we have two values of m, m1, which is equals to positive 1, and m2, which is equals to negative 1. And now, by considering these two values, it is not equal. Therefore, this is a distinct real roots. By getting the general equation, having distinct real roots, we have equate this into y, c1 x m1 plus c2 x m2. So therefore, we now substitute these two values of m into our general equation. We now conclude that y is equals to c1 x having a value of 1, exponent of 1, plus c2 to negative 1, or c2 over x. So that's our answer. Thank you.
Lord, I love the way you hold me. Oh, 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 oh.